Yeah, hi team. Let's get started. So in the last session, like we have seen how to configure the streaming replication. So as we know, streaming replication is real-time replication. So we have enabled necessary parameters at the master side, like wall level, hard standby, max wall senders, wall lock hints. Okay, and we have taken the PG base backup from standby by using the replication slots. So we know replication slots is one of the important for streaming replication to monitor how much lag we have in the standby, and it is aware and it keeps track of your standby if it is out of sync, and it keeps all your wall files in the primary in order not to delete. Okay, so we have taken PG base backup with the help of replication slots. So as a part of base backup only, we can configure the replication slot, or manually we can create replication slot by using create command. So create replication function. Okay, so this is one thing we have seen. And when you take the PG base backup with replication, and we also have one more option -R, right? So for configuration file. So it also add standby.signal file automatically, and it also add a parameter in the PostgreSQL.auto.conf. One is primary connection, right? So it adds the primary connection and it connects to the primary. So this option also very important when you take PG base backup. If you are not taking replication slot and this configuration file, okay, we have to do these things manually. You have to create replication slot manually, and we have to add primary connection details in the standby configuration file, and you have to point out to the master IP address and the user which we created for replication. Okay, and you need to allow these connections in the hpa.conf of master. Then only your slave server will connect to master and it will fetch the data as it generates, right? So we have a background process called wall sender and wall receiver. So both will communicate and data will be sent and received. So these are the two background processes which comes in the streaming replication. So this we have seen how to set up. And after this setup, we have also tested replication is working as expected. And streaming replication is a real-time replication. It will apply very quickly in standby. Whenever the transaction generates, it applies in the wall file very fast, right? So from wall buffers to wall files very fast, and it applies here as well very fast. Now, let us see some scenarios in the streaming replication. First thing is vacuuming. Okay, so first let's discuss about the table space, which is customized table space. So whenever we add any customized table space in the master, okay, so for this, what we are going to do, we are going to create a directory for customized table space, and we are going to add the table space in the master. Okay, so whenever you are in the replication, it may be log-based or streaming-based replication. Whenever you add any directory in the master, we should parallelly create the same directory in standby. Okay, so then you can type command create table space name, location, and the directory. Okay, this is mandatory. If you are not creating the same directory in the standby, then it would be a problem. So your standby will go down. Okay, so because it cannot able to execute the create statement command, and your master will goes down. So it's very important whenever you are creating any customized table space in your master, okay, you should check whether you have any replication, especially physical replication, not logical replication. If you have any physical replication, like just a second. Yeah. So this point we need to make sure, okay, whenever we are in the streaming replication, the directories we have to add in the both the sides. then only you have to find the create statement command. Okay, so this point we need to remember. Whenever you create the customized table space, you have to create directories at both sides. Now, second point, vacuuming. Okay, whenever we do a vacuuming, so as we know, physical standby, whatever the commands, okay, we execute in the master, it applies in the standby because it's a block to block copy, right? So, but we need to understand few things. Okay, whenever you do vacuuming, so what it happens, it will delete the data tuples and it also release the space to the OS if it is a full vacuum. If it is a normal vacuum, it only deletes the space. Sorry, it only deletes the data tuples, but it will not release the space to the OS, right? So this things like we already aware. But whenever in the streaming replication, whenever you do any vacuuming, it may be full vacuum or normal vacuuming, it also does in the standby. Okay, so if you do vacuuming, it will this command will automatically fire in the standby, and the data tuples will be deleted in the slave side as well. Okay, in the standby side as well. Okay, but only thing is there are some dictionary tables like PG stat all tables or PG stat user tables. So we have some dictionary tables, right? Stats tables. These are the dynamic views. Okay. Only thing is these stats tables will not update in the master, sorry, in the slave. Okay, for example, if you want to see how many data tuples and live tuples you have in a particular table, we see this view, right? We just add all tables. But if you see the same in the slave, okay, this will show 0. Okay, it will not update these values because all the dictionary tables will be not logged in Postgres. Okay, it will be not part of wall files. So that is the reason like these dictionary tables will be not replicated in the slave side. Okay, this point we need to remember. But vacuuming, this all things will be logged to the wall files. So those wall files will be pushed to the immediately on the fly to the slave and it will apply. So these points we need to remember. So vacuuming and full vacuum will reflect to standby. But dictionary tables, right? So dictionary tables will not reflect. At this point, we need to remember. Okay. And one more one more scenario in streaming replication, which is important. Okay. So for example, I have a table called EMP and it has some 1,000 records or maybe 1 lakh records. Okay. Now, as we know, standby server is in read-only mode. We will give the access to the application to fetch the reports, right? We can offload the load to the standby for any read-only reports. So in this case, what happens? For example, I'm trying to run the select statement. Select star from EMP where ID less than some 500. Okay. Assume this is very complex query. Maybe it has some joins or some things. Okay. It is taking almost to get output. It is taking some 20 minutes, right? So now let's assume that in the master side, from application side, okay, I want to delete this records. Deletes from EMP where ID less than 500. Whatever the data which I'm trying to fetch in the standby, okay, the same data I'm trying to delete in the master, right? Because of some application requirement, I don't want this data. I'm going to purge this data. So as we know, every 1 minute vacuuming process will kick off, right? Auto vacuum process will kick off, and this auto vacuum process will delete these data tuples. And whenever you delete these 500 records, it stores in the same table, and every 1 minute nap time auto vacuum process based on the condition, based on this values, okay, it will automatically kick off, and it tries to delete this records, right? And the same auto vacuum process, this wall center will send the data, right? I mean, it will apply all things in the wall files. The wall centers will keep and it will start sending the data. It also tries to apply here as well, vacuuming. So in this situation, still my select statement is in under process. So what happens, you may expect the conflicts in the streaming replication. Whatever the data you are trying to fetch here, which is taking long time, while this query is under process, you are trying to delete some sort of some sort of data in this table based on this condition. Okay. So in this moment, you may have some conflicts. Okay. So what happens is, to avoid this situation, okay, we have a parameter called hot standby feedback. So this parameter we need to make on. Okay, so when you make this parameter on, what happens? Okay, so this parameter will tell to the master that to not apply this vacuum, because the current data which you are trying to process, someone is executing in the standby. So don't do a vacuuming in the master. Okay, so this vacuuming process will skip. Okay, and you may expect some replication lag and some bloating in this situation whenever you do hot standby feedback on, because until the current transaction completes, okay, then only this changes will happen in the in the slave. Okay, so with this parameter you have advantage as well as disadvantage, right? But if you really needs the data which they are trying to pull, okay, in the slave, it is very critical job which they are running. Then based on the requirement only, we have to enable this parameter. Okay, if we not enable this parameter, whatever they are trying to fetch this record, it will get cancelled and they will get some error like conflict. Okay, once this is cancelled, immediately this delete statement will be applied here, and vacuuming will also applied in the slave. This is how you need to set up in the streaming replication. So third point is to avoid conflicts. Enable.
One question, this hot standby feedback on should be, that parameter should be set on the
standby
primary
side.
Or on the standby
Yeah, standby side. Yes. Yeah, so if we set this parameter, what this parameter do, actually internally we have MVCC, right? So MVCC will work based on the Xmin and Xmax values. Okay, so this standby parameter, hot standby parameter will tell based on this Xmin value, don't purge any dead tuples in the master. Okay, don't apply the vacuum, it will just skip the vacuuming. Okay, when you skip the vacuuming, again you have bloating tables, bloating, I mean, the data will keep on increase, right? So you may have bloat. Okay, as well as you may observe some of the replication lag as well, because until this transaction completes on this particular table, basically it has to apply this vacuuming as well, right? So you may expect some delay, but not that much. So it entirely depends on application team. You can configure this parameter. If they really want that report, okay, in the standby to be completed, then we can enable this parameter. If not that much important, we want the real-time data replication. Okay, we can disable this parameter, and whatever the changes happen immediately, it will reflect in the slave. So at that moment, if they are doing any long-running transactions, they may get failed. Only if based on that data, whatever they are trying to fetch the records, right? So only that record, if they're trying to delete only, we may face this issue. So this we can say some small drawback. in replication because of the MVCC architecture in Postgres. Okay, but yeah, so this can be achieved with this parameter as well. Okay, so these are the 3 points that we need to remember in the streaming replication. So let's do one thing in okay, check what is the IP. It's 11. This is my standby. So this is 4. Okay, let me check if my Postgres is running. It's running. And we have all receiver, which means this is a standby. Okay, so this is in recovery mode. We know this is standby and this is primary. So let me check TP1. And let's check whether it is replicating or not. Okay, it is immediately reflecting, which means replication is working fine. Okay, so now let's do a vacuuming process here and see how it have this database. Okay, I have this many records. If I want to know how many data tuples and how many live tuples I want, I can just check from pgstat all tables, right? So here I can get how many live tuples and how many dead tuples. And I want lost vacuuming, lost analyze, right? So from this view where okay, so I have this. Okay, let me do analyze because I may okay. So currently I don't have any data tuples. Okay, let me run the same query in the standby. Okay, it's showing 0. Even in standby, we cannot perform any maintenance like analyze, for example. Let's try. Okay, it is telling cannot execute analyze during recovery. So we cannot do any vacuuming or analyze directly in the standby. Okay, so it now, so probably let me try to do a delete. Okay, this records has been deleted. And why it's taking this much time? Count 0. Okay, deleted everything, I guess. Okay. Okay, fine. So now we don't have any live tuples. and all has been deleted from the table, right? So let's go and see the same query in the standby. Okay, so it is not updating any data pulse and when is last vacuum performed, because this pg stat all table will not generate any uh, wall entries in the wall file. So that is the reason it will not show anything here. But if you see the count from a table, it should reflect, because the same else statement would have applied here as well, right? So it is showing 0 because everything has been purged from the, everything has been deleted, right? Based on the condition, it has deleted. Now let's do a vacuum operation. So let's do a full vacuum. So probably we may understand the things. So before we do that, let me take the table size. Okay, so table size is 671 MB right now. So let me check same in the standby. It should be same, right? So both are same. And only thing is it is not updating the stats table. Okay. Now before I do this, let me take the PG relation file path of this employee table, because I'm going to do a full vacuuming. PG relation file path. Yeah. So this is currently my this employee table OID, right? And this is the path of my employee table. Now I'm going to do a full vacuuming. So for this vacuum purpose, I'm just giving full. Okay. Let's see. Now it has deleted, okay, and you see the size is 0 because there is nothing in that table. And if you see the relation path, sorry, file relation path, okay, the OID is 327994, right? So let me see here. It is 32784, right? So both has been changed. This is expected, right? So when we do full vacuuming, the file name will be changed because it will rewrite the entire content to the new page, right? So let's do same thing here. 32794. It has updated the latest one. And if you check the size, it becomes 0, which means whenever you do any vacuuming, it also does in the standby. Only thing is it will not update to the stats table. Okay. So this is how it works in streaming replication. Sorry. Do you have any questions? Yeah. So whenever you do a full vacuuming, okay, the file path will be changed and the same file path will also change in the standby because it's a byte-to-byte copy. And only thing is the PG, all the stats table will be not updated. That's it. So remaining operations will, everything will be applied in the standby. Okay. So these points we need to remember. Okay. Now let's do a failover scenario. Okay, in the streaming replication, we know we don't have the inbuilt functionality to do automatic failover. We can only do a failover, manual failover, right? So even in the streaming replication as well. And for example, let's assume that my standby database is not available due to some reasons. Okay, so I have my standby right now in sync. Okay, but the thing is my primary is not available. Now I want to do a failover. I have a situation that my primary is not coming up due to some hardware issue or maybe any software issue. Okay, now I want to do a failover. So as we know, we can do a failover with 3 options. One is PG promote function, and we have trigger file, and we also have pgctl promote utility as well, right? So either way we can do that. Okay, so now what I can do, I can just use pg underscore promote function, okay, to do a failover. Okay, now let's check whether this standby is in recovery mode or not. Okay, it is not recovery mode. It converts to read-write mode. So let's go and check the alert log. Okay, so what it does is it applied all the wall files and everything. And let me see. So it does the 4 checkpoint and it started the cluster. Okay, it applies all the archives, whatever it has done. Okay, and then it will accept the connections. Okay, so now this becomes my primary cluster, right? Because I have did a failover. Now let's assume that after 4 to 5 hours, my primary is back. Now I want to join this particular node into my standby as a this is currently primary. Even we converted this as a primary, right? Now after few hours, my old primary came back and I want to join this as a standby and I want to join this into this replication. I don't want to do again full replication. Okay, there is a utility called PG rewind. Okay, PG rewind. So with the help of PG rewind, we can able to do a incremental backup and we can apply the changes. Okay, so this is the utility to join your node back to the cluster. Okay, as a standby. Okay, so this utility we can use and we can use the source which target directory you want to modify and the source data directory you want to sync. Okay, these are the two important options. With the dry run, we can able to see how whether we can able to join node or not. Okay, so if dry run is successful, then we can run the actual run and we can able to rejoin this node again back. Okay, so this option we have. And anyhow, this option we are going to cover in the rep manager. So that is the reason right now we are not discussing this PG rewind. So probably on Monday, we are going to do this PG rewind with the help of rep manager. Okay, so this is how we can do with the PG rewind. Okay, before that, let's discuss about the rep manager before we jump into the rep manager things. Okay, what is a rep manager and what is the advantage of rep manager, and we'll see. Okay, so basically, as we know, as a part of Postgres inbuilt, we don't have switchover kind of things. We only have failover. That too, we need to do a manual failover. So rep manager is one of the open source tool. Okay, most of the companies they use this rep manager. It's like we can say data guard broker. Okay, so we have to configure this rep manager package. With the help of rep manager, we can set up the automatic failovers and we can also do a switchovers. Okay, that these two advantages we can get from rep manager. This is not part this is not part of the core Postgres, right? So that is the reason they have developed this package and we can use this tool. This is an open source tool. We can use this for switchovers and automatic failover kind of options. Okay, so let's discuss more about the rep manager. So we can see introduction of rep manager and what are the components of rep manager terminologies, and automatic failover, how we can configure, and how we can do a switchovers, and we can also do a standby follow. Okay, we can do the node rejoin in the cluster as well. Okay, how we can do the node rejoin followed by cluster show commands and events. Okay, these are the some utilities how to monitor the rep manager cluster related replications and so on, like how we see in the DGMGRL like show configuration in Oracle, right? Similarly, we have cluster show utility to check the gap and it gives the primary and standby configuration and everything with the help of these utilities. Okay, so this all we are going to cover even with the practically. Okay, so today we can cover the theoretical part. Probably Monday we can set up everything practical, how we can set up a replication with the rep manager. Okay, so as discussed, Rep Manager is an open source tool for managing the automatic failovers and switchovers, okay, in PostgreSQL. And this Rep Manager supports, okay, and it enhances the built-in streaming replication features, okay. So basically it supports only the streaming replication. On the top of streaming replication, it supports some enhancements like automatic failover and it also does the switchovers, right? because switchover is very important for business continuity plan, right? So even in real time, we used to do business continuity plan for 6 months. We have to run the primary in one location, and other 6 months we have to run in different location for business continuity plan, right? So switchover is very important. And even if you do any kind of maintenance activity, so we can do a switchover and we can hand over that standby cluster to the any OS team or any other teams for doing any maintenance, right? So this can be achieved with rep manager. And rep manager also supports like multiple standbys. Okay, so we can add multiple standbys in the rep manager and it can handle. Okay, and it also have something called witness node. Okay, so that we are going to discuss in the coming slides. So number of standby servers also you can manage in the rep manager. And important thing in the rep manager is there is a background process called rep manager D. There is a background domain. Okay, we can say domain process who will actively monitor the replication, everything. So this rep manager D process will monitor, okay, whether the standby is actively replicating or whether it is not available. Everything will be managed with rep manager D background process. Okay, so this process we have to enable while we configure the rep manager so that it actively monitors your replication. And we have a command line utility called rep manager. With the help of rep manager, we are going to set up everything. Like we are going to do all the administrative tasks like setting up the standby server. We can we can do a failover, we can do a switchover, okay, to display the status, everything we are going to do with the rep manager. Okay, rep manager is one of the command line tool. With the help of rep manager only, we are going to enable all these activities. Okay, all the administrative kind of tasks can be done with the rep manager. And apart from this, we also have rep manager D backend domain process as a part of rep manager. This is mainly actively monitors your replication. Like for example, if your standby is due to some reasons it is not available, okay, this rep manager D process will keep on ping your standby mission every second or 2 seconds. It will keep on pinging your standby. If it is not available, this rep manager D is aware, okay, your standby is not available because of some reasons. And this can also do a automatic failover because of the rep manager D monitoring. Rep manager will understand that your standby is not available. Then based on the parameter which you have enabled, so basically we have to configure the rep manager.conf file where we have to register our primary and standby details in the configuration file. And we also need to mention parameters whether you need an automatic failover or you don't need an automatic failover to be done if your standby is not available. So those all settings we have to add in the rep manager.configuration file. Okay. So based on that configuration file, your rep manager D process will keep on monitors and it also do an automatic failover, right? Because whenever DBA is so DBA is not needed, right, to do a manual failover. So maybe in midnight something happened to your standby, your primary, and your primary is not coming up, okay, or something. So you can do an automatic failover without any DBA intervention. So this is one advantage we get with the rep manager, right? And with this rep manager D, we can also configure the notifications events, like if your standby is not in sync, okay, and it's not available, either you can configure the notifications and DBA can do an failover if you don't want the automatic failover. Okay, so these are the two important components as a part of our rep manager. Now we need to understand few of the terminologies as well. Okay, we have a replication cluster. Okay, replication cluster we know. So whatever the cluster which is a part of our streaming replication, those clusters we call it as a replication clusters. And we have a node. Okay, so node is a single Postgres server. It may be master or standby. So we call it that as a node in the rep manager terminology. And one more important terminology is upstream node. Okay, so this is very important. So the node which connects a standby server connects to, which means, for example, you have a master and slave configuration, and your standby will follow the primary, right? So in that moment, we call that standby as an upstream node, whichever the node which follows to the master, okay, or whichever node which connects to the server. So that we call it as a upstream node. So whenever we do practical, you will understand better what is upstream node basically. So in case of if we have multiple standbys or cascade standby, so one standby will follow the other standby, right? So in that moment, that particular node called it as an upstream node. If we have only single setup like single master and single slave, so that standby will follow your primary, and that node we call it as an upstream node. Okay, if you have multiple standbys or cascade replication, then the case will be different. So whichever node is following, maybe it may follow primary or it may also follow the standby, right? And failover. So this we already know, right? So failover, if because of some reasons your primary is not available, either we can do an automatic failover or we can do by DBA intervention. Okay. If you use the rep manager D, okay, which reduces the minimum downtime because it wait for maybe 15 minutes or something based on our configuration, how we set up. If within 15 minutes your primary is not available, then automatically you can do a failover. It will take care by rep manager D process. Okay. Or DBA can do. And we also have the switchover, right? So as we know, whenever we are doing any maintenance activity like hardware failure, replacement or something, or any operating system upgrades, okay, so we don't need any downtime. We can do a switchover and we can hand over the standby database to OS team or any hardware team. And once the maintenance activity done, we can do again switch back and we can hand over the other server, right, to the OS team or any other teams. So which reduces much downtime. And we can also do a business continuity plan with the help of switchover. Right? And we have a something called witness node. So this witness node is not part of your primary and standby cluster. So we have to configure a separate server called witness node or witness server. So this witness server is something comes into picture whenever you have multiple standbys. Okay. So what is the advantage of this witness node is whenever you have multiple standbys, if your primary is not available, then this witness server will make sure that yeah, this witness server, just a minute. Yeah, so this witness server will make sure that one of your standby, it will promote as a primary. This witness server will decide which standby is best suitable for doing a failover. Okay, if you have multiple standbys, right? This is something which we need to configure separately, separate mission. Okay, it is not part of your primary and standby. So this is very one more feature you can get, which is called something witness server. If you are if you have multiple standbys, this witness server will decide which standby has to go to a new primary. Okay, and it also contains all the metadata of your rep manager, like you have to register your primary and your standby as well to the witness server, and this witness server will keep on monitor your both the primary and standby. It is like it keep on voting and it writes in the witness server, right? And whenever you have any primary is not available and you are in the failover situation, this witness server will decide which standby has to promote as a new primary if you have multiple standbys, right? Because otherwise DBA has to do manual work, right? If you have multiple standbys, you have to verify whether the lag you have in both the standbys and which standby is best suited to promote a new primary. So those manual work we don't need. This witness server will take care of checking all the pre-checks, like whether you have any lag or something. So all the pre-checks, this witness server will keep on checking, and this will decide which standby has to go as a new primary.
So do we need to install any client software here on the witness server?
We need to install Postgres client as well as Rep Manager as well. So Rep Manager software we need to be configured. Even this Rep Manager we have to configure at the primary server and also slave server, I mean standby server. And witness server also we have to configure the Rep Manager package. Okay, so and you need a Postgres server as well, right? So you need to it has to write those information in the witness server, which means in one database it writes all the metadata of your primary and standby. So we also need a separate Postgres server as well in the witness node along with the Rep Manager.
So any other files to detect that all the primary servers?
No, we don't need any other files. With the help of Rep Manager command utility, we can register your primary and your standby details, and you need to allow the hpa.conf both the primary and standby in the witness server, so that witness server will able to connect and it fetch all the metadata from the primary and standby, and it's keep on monitored your both primary and standby. Okay, this thing will come into picture whenever you have multiple standbys. Otherwise, if you have any single standby, we don't need this, right? Because we have only one standby and we don't have other option. We have to do a failover to that standby. If we have multiple standbys, then we can take this advantage and we can use which standby server is best suit for new primary to do a failover. So at that moment, we can able to configure this witness server. It's not mandatory. It's up to us to use this functionality or not. Okay. If you
on what basis it can identify that this is the best server that I can switch to the standby?
Yeah, basically what it does is it writes the information of your availability of your primary server. It internally do a ping command. So it's keep on pinging every second or 2 seconds to your primary and standby servers, and it writes the heartbeat information. Okay, that is one thing. And at the database level, it also writes the replication lag, okay, based on the PG stat replication, right? So if it has any lag or not, okay, what is the last LSN it has generated in the primary and what last applied in the standby. So it has those all kind of information in the witness server. So based on that, this witness server will decide which standby is best suited for doing a failover. Okay, if both are in sync and both standbys is it's like very nearby sync, okay, with the primary, it decides any of one standby. Okay, if one standby is not available or one standby having any lag or something, it gives the another standby which is already in replication, right? So that standby it generates as a new primary. So based on this OS ping command and database replication, it's keep on monitors and it decides, okay, which standby has to become a new primary, and it writes all the metadata information to any schema. We have to create a schema to write all the metadata information of the Rep Manager.
Okay.
Yeah. So this is the advantage of Rep Manager. We can use automatic failovers, switchovers, as well as if we have multiple standbys. DBA no need to manage all the things. Witness server will take care of promoting and automatic failovers. Okay. So this is one-time setup we have to do, and everything will be managed by the Rep Manager. Yeah. So these are the important parameters that we need to configure when we want to set up a streaming replication with the help of Rep Manager. So most of the parameters are like same parameters as normal streaming replication. Only one new parameter we need to add that we'll discuss. Okay, wall level we know we have to set replica, and this determines like how much information it has to write in the wall file, right? So we have to configure this as well. And wall log hints is one of the important. So with the help of PG rewind capabilities, we can join the node again back as a standby. If it is out of sync and it comes after few hours, okay, we can rejoin that node easily with the help of PG rewind. And this PG rewind also supports in the rep manager. So with the help of rep manager also we can do, or in a normal streaming replication also we can do this PG rewind. Okay, this also we can see one example practically how we can join the node back to the replication cluster. Okay, and as usual we have max wall senders. By default it tends, we can leave this as a default, and this will make sure the connections, okay, from standby to primary as a part of your wall senders and wall receivers, right? This is also very important parameter that we need to configure. And as we know, hot standby, this will make sure it allows the read-only connections, okay, to the standby when it is in the standby role. So this we have to configure, and this we can ignore for the primary. Even if you configure for primary, no problem. Standby we have to configure. Okay, even though if you configure in the primary, no matters. But when you do a switchover, this parameter again has to be applied in the standby, right? Because that becomes a standby. So there is a reason we apply on the both sides, primary and master side. And the only thing is, this is the new parameter which we need to add as a part of rep manager. Okay, shared preload libraries. You have to assign this to the rep manager. So when you add this parameter, what it does, it loads all your libraries of your rep manager package. So basically this rep manager can be installed in two ways. You can do with the RPM method with the m install, or you can directly download the package, rep manager package from the Git of the rep manager community, and we can use this. Okay. So even PostgreSQL community also, they are recommending this rep manager to use as a part of your switchovers kind of functionalities to get. Okay. Maybe soon in new versions, maybe community itself, they will have these functionalities like automatic failover or maybe switchovers. Okay. But for now, we don't have any features to do a switchovers and automatic failovers. But again, DBA can write a script, shell script or any Python script to do an automatic failover with the help of PG promote, right? You can configure the scripts and you can keep on monitor your replication. If your primary is not available, probably you can do automatic failover with the help of scripts if you don't want to use rep manager, right? Even that is possible. But if you use rep manager, you will get the switchover kind of activity. The roles can be changed. Primary role will change to standby, and standby role can change to primary with the help of rep manager. Yeah, so that's it. Theoretical part we have in the rep manager. Probably in the next session on Monday, we'll see how we can configure this rep manager, and we can see how to do a switchovers and how to do a failover. And after failover, if your old primary, you want to rejoin as a new standby into the cluster, how we can do with the help of PG rewind in the rep manager. Okay, these things we can see on Monday class. Okay. So any questions on the rep manager part or any doubts on the streaming replication part?
Yes, Suresh, one question with reference to the streaming replication. The three things that need to be noted down regarding create table space and vacuuming and all that, right? You also mentioned that the dictionary tables, those changes are not reflected to the standby.
Yes.
So what is the impact in case if we fail over the database, the slave becomes primary, having no knowledge of the dictionary tables changes?
Yeah,
will that have any impact?
Actually, I can say we have to do a analyze of full database, or even your auto vacuum process will take care of doing the stats, right? So at that moment, it will update all the stats to the table. Okay. So apart from this, we don't have much impact related to this dictionary tables. your auto vacuum process, once it converts to the new primary, your auto vacuum process will take care of updating all the dictionary tables. Okay. But even if you want to do manual, you can do an analyze command for the cluster. With the help of analyze, it has all the up-to-date stats and things. Okay. So this it's good to have analyze command, right? After you do a failover. So that it have all the up-to-date stats and we don't have any issues. Otherwise, our auto vacuum process will take care of doing these things because since it's in standby role, the auto vacuum it copies from block to block from the primary, but in its own in the standby, your auto vacuum process or analyze process will not kick off in the standby server. Yeah.
Okay, got it. Thank you.
Yeah. Any other questions?
So any pre-checks before we switch over or failover?
Yeah, obviously we need to check the if it is a rep manager, we will check the events like whether your standby and master is in sync or not. Okay, what is the LSN? Like how we do in Oracle, right? We check the whether it is ready to convert to the today's switchover. So those things we have to do. Probably so that we will show in the Monday session, like what are the pre-checks we need to do. Mostly the replication lag we have to check. And we have to check whether we can able to convert. Okay, even we can do a dry run, whether your standby is able to convert as a primary or not. So with the help of dry run, we can check the whether it is capable of doing a switchover or not. So those things we have to do as a part of pre-checks.
Okay. So in Oracle, we have one parameter. So is there any single parameter that we can verify it's able to connect or not?
Oh, you mean to say the replication lag?
No, switchover underscore status.
Yeah. Here we don't have that kind of dictionary column, but we only need to check with the rep manager events like cluster show. Okay, it checks all the pre-checks whether it is able to convert or whether it is able to do a switchover or not. So cluster show utility, cluster events. So we can see that how we can do on Monday. Okay. So with the help of that utilities only, we can able to do pre-checks. But we don't have any kind of that Oracle, as you said, that column, right? So we don't have that kind of things here.
Good.
Yeah, any other questions? Yeah, if we don't have any
one, one question. It's like, is there any concept like we can open the standby as in read-write mode like in snapshot standby here?
Oh,
like
no, we don't have...
if there is any requirement from application team that they need some testing for the with the production data, but we cannot allow them in the production so that we can restore.
Yeah, we don't have feasibility to convert the standby as a snapshot standby and again bring back to the normal standby. The only thing is we have to take the backup and you have to give the another standby. I mean, you can clone this master and instead of opening in the read-only mode, you can directly open in the read-write mode. How we do point-in-time record, right? We take the entire PG-based backup and push the archives, and you open the cluster and give to the application team. Again, you can drop that particular database, but in the same standby, we don't have option to convert as a snapshot standby.
Okay.
Yeah. Yeah. Any other questions? Yeah. If Rover has any questions, probably we can catch up on Monday for the practical part of Rep Manager. Okay. Yeah.
Thank you.